All right, guys. Hi, it's Professor Walker Wall, and today we're going to talk about dimensional analysis. This is the one thing that you really need to get. Why? Because it changes how you think, and that's going to be imperative when we go further into the course. All right? So again, don't put this YouTube video up on your mount in your car. You can't do that. You can look at it on the train, you can look on in the bus, but while you're driving, you cannot have anything up there but your navigation. Don't get a ticket like I almost did. Moving right along. Dimensional analysis, the joy of your lives, and significant figures. So now, it's 4 easy steps. Nothing much, very straightforward. The first thing I want you to do is to always write a mathematical expression from the math. So you're supposed to be doing car chemistry. So think, how many meters, how many is the question mark, meters is what you're looking to find, Rn, that's the equal sign. Rn means the equal sign. 7.2 nanometers. Something real simple. So question mark meters is equal to 7.2 nanometers. Now I know you already know your SI prefixes, so I don't have to go over that with you, I'm sure. Moving right along. Step 2. You write a path of units only, beginning with the given units. So we know how many nanometers, and we're just trying to find meters. Now this is just the beginning. This path is going to save your hiney. The path shows you where you have to go. And I'm telling you, in my class, it gets pretty complicated. So make it your business to understand where you're starting from and where you have to go. Because if you don't know where you're going, you're going to end up anywhere and you're going to be wrong. We don't want that. Step 3, write definitions, which really means fractions, for each step along the path. Okay, this is a simple one, right? The only thing I'm doing is I'm going from a nanometer to a meter. And you know your SI prefixes. You know that it takes a whole bunch of little things to make one big thing. And a nano is smaller than a meter. So 1 times 10 to the what? 9, 9. 1 times 10 to the 9 nanometers is equal to 1 meter. Now that's a fraction that you can make 2 different types of fractions. You could put the 1 times 10 to the 9 nanometers in the top and the meter in the denominator. Or you can flip it. You can say 1 meter in the top over 1 times 10 to the 9 nanometers at the bottom. That's all you have to do is understand that relationship and you can solve it. So that's the last step. All you have to do is to choose the appropriate fraction. Choose whichever fraction, so you can say, bam, cancel it out. Bam, cancel it out. So question mark meters is equal to 7.2 nanometers. Okay, you saw that in your head, right? That's where we started from. Now, if I'm going to do bam, where must my nanometers be? In the numerator or the denominator? If the nanometers is what I'm starting with, I got to go bam, put it in the denominator of the fraction. So question mark meters is equal to 7.2 nanometers times 1 meter over the 1 times 10 to the 9 nanometers. Plug it in your calculator and you get 7.2 times 10 to the minus 9 meters. Think about it. You can do this. It's not difficult. Take your time. Work the problems in the back of chapter number 2, because our problems are going to start off small and we're going to build and build and build. And it's called Reading is Fundamental. Okay, guys, let's try this now on the board so that you can see it. because I was trying to get you to think about it in your mind. All right, so we said question mark meters, and you know an M is a meter, is equal to 7.2 nanometers. Now you know your SI prefixes and you know your SI prefix definitions. So we're going to make a path next. We're starting off with nanometers and we're trying to get to a meter. And knowing your SI prefixes, you can easily make a definition. So you can say to yourself, 1 meter is equal to 1 times 10 to the 9th nanometers. Takes a whole bunch of little things to make one big thing. Now, I can always make two fractions from any definition because the definition means 1 is equal to 1. I can easily say 1 times 10 to the 9th nanometers over 1 meter. Or I can say 1 meter over 1 times 10 to the 9th nanometers. So let's call this fraction A and this fraction B. Which fraction should we use? Noting what I said previously. Bam! You got to cancel it out. Well, obviously, B's going to win, right? Because I've got to cancel out those nanometers. So when I plug this up in here, just take that same beginning equation that you came up with from the words, and I say 1 times 10 to the 9th nanometers over 1 meter, you can easily see that those nanometers do what? Cancel out. Now, if you don't know how to divide powers of 10, I need you to just see me in class or look in the back of your textbook. But this is so easy. Just plug it into your scientific calculator. 7.2 times 10 to the 9th, make it minus meters because you're subtracting your powers of 10 when you divide. Now, see me in class. Thank you very much. You've been what? Marvelous.